Good morning, everyone. My name is Saja from E section. Today I am going to present my topic on dead code elimination, application in removing unused code. Dead code elimination is a very important optimization technique in compiler design. It helps in improving performance by removing unnecessary instructions. In modern software development, efficiency is very important because program needs to run faster and use less memory. In this presentation, I will explain the concept, examples, types, working, and applications of dead code elimination. Introduction to dead code elimination. In real world programming, especially in large software projects, developers often write extra code. This can happen due to debugging, testing, or modifying existing features. Over time, some parts of the code become unnecessary, but they remain in the program. This type of code does not affect the final output, but it still consumes memory and processing time. This unused or unnecessary code is called dead code. Dead code can make programs slower and harder to understand. Therefore, removing dead code is very important for improving program efficiency. What is optimization? Optimization means improving the performance of a program without changing its output. It focuses on making program faster, reduce memory usage, and improve efficiency. For example, if we take two programs given the same output, but one runs faster, then the program is considered optimized. Code optimization is usually done by the compiler automatically. There are many types of optimization, and one of them is dead code elimination. This technique removes unnecessary part of the code and make the program better. Definition of dead code. Dead code is the code that does not affect the program output. It can be two types. First, code that is never executed, such as code after a return statement. Second, code whose result is never used, such as a variable that is calculated but never printed or written. Since this code does not contribute to the final result, it considered unnecessary. The process of identifying and removing such code is called dead code elimination. The core concept of dead code. Here, in simple way, if we say, if a question asks, if we remove the line of the code, will the output change? If the output does not change, then the code is not useful. The compiler removes such code and keeps only the necessary part. This helps in reducing program size and improving execution speed. The most important point is that output remains output must remain exactly the same. The key idea impact on an output. Here, the only code that affects the output is important. Any code that does not influence the result can be safely removed. This ensures that code optimization program behaves exactly the original program. This concept is very important because correctness should never be affected during optimization. Taking a real life example of dead code. Let us understand this with a real life example. Suppose you are solving a problem in an exam. You do some rough work calculations, but you do not use them in the final answer paper. This rough work is not useful. Similarly, imagine carrying extra books to class but never using them. This unnecessary effects and waste of resource. In the same way, unused code in a program is waste and it is called dead code. Removing it makes the program cleaner and more efficient. Here we are going to see the example of dead code. we took an code in int a is equals to 5, int b is equals to 10, int c is equals to a plus b. Here, the variable c is calculated but never used, so it does not affect the output. As if we remove the third line of the code, also the output will be never affected. M- Moving to the example of non-dead code. Here we look an example like int a is equals to 5, int b is equals to 10, int c is equals to a plus b in the printf statement. Variable c is used in the output, so the printf statement must be present in the code. It directly affects the program result, and removing it will change the output. And this is an example of non-dead. The types of dead code. There are four types of dead code: unreachable code, unused variables, dead assessment, redundant. First one, unreachable code. Code that is never executed. Unused variables. Variables that are never used. The value assigned but never used are called dead assessment. And and if calculation with no effect on output is called redundant. First one, unreachable code. Code of after a return is never executed. As if we can see return 0 and then printf statement, the printf statement is not going to be executed here. Such code is called as unreachable code. Unused variables and dead assessment. First, unused variables. Here int a is equals to 5, int b is equals to 10, return a. Here we are returning only the a. The output is 5 and the b variable was not used. So it is an unused variable. Such variables, such b variable is called as unused variables. Assessments. Dead assessment. Assessments whose values are never used are called as assessment. Working of code dead code optimization. The compiler performs dead code elimination during optimization. First, it analyzes the program. Then it defines which variables are used and which are not. It checks which code is reachable and it removes unnecessary code. And here the techniques used are control flow analysis and data flow analysis. Control flow analysis check reachable code and data flow analysis checks variable usage. Next, here we can see before and after dead code elimination. Before, the code length was lengthy, and after removing the dead code, the code execution was small. The unused variables does not affect the output are removed in the after optimizer, and it simplifies the code and fast program execution happens here. Applications and the advantages of dead code elimination. Applications. It is used in compilers of optimization and improves software performance. It is also used in web applications, removing unused code. It is useful in embedded systems, saving memory. And the advantages of dead code elimination. It improves fast execution and improved efficiency, reduces memory usage and clean and simpler code. Conclusion. In conclusion, the red code elimination removes unnecessary code of programs. It improves performance, efficiency, and readability. It ensures that programs run faster and use few resources. It is an essential technique in modern compiler design. Removing unused code makes program faster, cleaner, and more efficient. Thank you, one and all. I hope you understand the concept clearly.